Hello and welcome to your Lab 12 instructional video on glacial geomorphology and landscapes. So this lab will take us into the understanding of glaciers, the size, the speed, and what type of landscapes are left behind after the formation and development of glaciers. Now, a glacier is a long living body of ice that moves under the influence of gravity and its own weight. It develops on land as compacted snow and is transferred into ice. There are really two types of glaciers that we'll identify in this lab. Glaciers that are confined to valleys are called valley or alpine glaciers. Such glaciers are relatively common in the northwest United States and Alaska. Those glaciers that are not restricted to a valley but cover large areas of continents are called continental glaciers. Now, we will learn a little bit more about what is the zone of accumulation versus wastage. Classic photo here in Yosemite with two very important people. Any guess who they are? I'll give you one. The one on the right is none other than John Muir. The one on the left, Teddy Roosevelt. Teddy Roosevelt made this slide here because he's the one who really set aside Yosemite as a national park. Moving down here, we'll Google more about learning the Jakobshavn Glacier in Greenland. It's the fastest moving glacier in the world, moving somewhere between 12.5 to 16.4 kilometers per day. You will need to calculate then what is it on average moving per day in meters, and you'll be quite surprised. So this is really a vocab heavy type activity. I do have some supplemental videos on the modules. So we're going to be first matching and defining these vocab words. The thing to keep in mind is that there are lots of right answers, but there are definitely wrong answers too. So as an example, once you learn what a horn is, a pyramidal peak carved by Cirques, you'll find that there's a horn there, a horn there, a horn there. It's having you just to identify one. So your job is to work through these words, these vocabs, introduce their definitions, explaining how they were developed and formed, and then to match them on the diagram. So as an example, I'll use cirque as an example. So cirque is French for amphitheater. Cirques are the first place in which a glacier develops. It's the first place to freeze, last place to melt. We know that as water freezes, it expands. So in doing so, it creates these very large horseshoe-looking amphitheaters. This is a cirque. This is a cirque. There's a cirque. Everywhere a cirque, all over the place in here. Very prominent and very large feature. We can identify arêtes that are within the cirques. Cirque here, nice blade-like ridge in between. Moraines. Moraines are very dominant features of material that get built up. When I think of moraines, I think of when you're at the beach and you stick your hands in the sand, you push the sand away, and you create a big pile of sand at the end. You created an unconsolidated pile of debris, otherwise known as a moraine. These words just distinguish where it is, at the end or somewhere in the middle. So that's a great example of a terminal moraine. And because that moraine exists, it's created a lake. As you move forward, here's some additional features and definitions going within the moraines, different types of moraines. Here we go with some valley floor features that can often be found by continental and by the terminus of many other glaciers. Again, drumlins, kettle lake, eskers, kames. They're depicted here in the diagram, but you need to make sure you understand these features enough that you can not only match it, but if I had a definition, you would know what I'm talking about. The last one has you build a model at the end here. Very easy model. This is an Icelandic glacier model, which will allow you to answer these last three questions, 6, 7, and 8. The last part of this lab, two very 1964 renditions of glacial features. Again, this is, I'll turn it to its side so you can see it a little bit easier. Your job is to find as many features as you can on here and then to be able to explain to me what they are, because you might get a diagram like this on the final that says, well, which one of these best portrays we'll say a truncated spur, And you would have to know that it would be this feature here, was pointing at this ridge. That is an excellent example of a truncated spur. Same thing here. Let me turn these to the side. Here you have 4 different features. This one's all ice. This one's got a solid ground moraine that's been deposited after the ice has melted. This is a lake. Here we have a nice chain of lakes and paternoster lakes. I'm asking you on this page to find 10 different glacial features total amongst these 4 images. So just a little over 2 each. Very easy to do. Again, the key with these last couple labs, they're not as activity-based as the previous ones because I'm really trying to utilize these labs to help those taking the lecture course be prepared for the final exam. The final exam is very feature heavy, in which you have to be able to identify features based off of these diagrams. And vice versa. If I gave you a name, could you find something like that on the diagram? Once you've completed this lab, don't forget to convert it to a PDF and submit it to Canvas. That being said, thank you very much for completing these labs. Good luck on your final exam, and we'll talk soon.